Hello mathematicians, in this video we're going to be looking at evaluating piecewise functions. We'll start out with a review on evaluating regular functions, and then we will look at evaluating piecewise functions from a graph and from equation. So let's see here. I've got an example on the screen where it's asking me to evaluate. It says if f of x is equal to negative x squared plus 10 over 5x, what is the value of f of negative 2 to the nearest thousandth? All right. So remember, with functions, what goes inside the parentheses here, that's our input. And our input is represented by x. So I'm going to go ahead and take this negative 2 here and plug it everywhere I see an x in my equation, which will look something like this. F of, well, it's not x anymore, it's negative 2. So f of negative 2 equals negative 2 squared plus 10 over 5 times negative 2. And you'll notice everywhere I plugged in a negative 2, I put parentheses around it. That's important because if you're doing a kind of complicated problem like this one, order of operations really matters. So up on the top here, we're going to start, to evaluate this, we're going to start simplifying this fraction. And we better start inside the parentheses. Well, nothing to do there, so I'll go to exponents. Notice how this negative 2 is being squared, and then there's a negative out front. So order of operations, be sure to square the negative 2 and then apply the negative. When you do that, negative 2 squared is positive 4, and then the negative makes it negative 4 again. So negative 4 plus 10 over negative 10 comes out, let's see, that's 6 over negative 10. Well, we don't need to round this one to a thousandth. That comes out very nicely as negative 0.6. So that's the idea with evaluating. You go through the problem and you plug in the value for x everywhere there's an x, then simplify it down. Sometimes, of course, you might need to do things backwards. Maybe we give you the output first, and then you need to find the input. So that's what we're looking at in this second example here. Let's take a read. Given that g of x is equal to negative 5x plus 5, solve for x when g of x equals 10. Alrighty. So in this problem, we have an equation for g of x, and then it says to find x when g of x is negative 10. Well, g of x is the full expression. So I'm going to take this negative 10 here, and I'm going to plug it in. And when I plug it in, I'm going to plug it in for g of x. So that's going to replace the entire left side of my equation. So I get negative 10 equals negative 5x plus 5. That's a gnarly looking 5. There we go. That's better. So negative 10 equals negative 5x plus 5. Notice how the entire g of x has been replaced. There's no g, there's no x. The full g of x is replaced with a negative 10. Now I'm going to go through, solve the equation for x, and we'll have the answer. All right, so quick solve here. Subtract 5 off of both sides. That's negative 15 equals negative 5x. Then we'll divide by negative 5, which gives us positive 3 equals x. So that would be our final answer here. Another way we could express this answer, since we're given that g of x equals negative 10 to start with, is like this, where we could say g of 3 equals negative 10. That gives us that input-output pair, where 3 is our x value, our input, negative 10 is our output. So that's another way to communicate that answer. All right, that's a good little review there. Let's take a look at some piecewise functions, and we'll look at them on graphs to start out. So on this particular problem, we can see that this is a piecewise function because it's mostly a parabola, but then there's one little piece of it that's not where it's supposed to be. The vertex is missing, and there's a point up high where the x value is for the vertex. So at this particular location, at x equals 1, we jump off of the parabola up to this point. So there's one small piece of this function that differs from the parabola. So we'd call this piecewise function. So the question asks us to find f of negative 2. Well, on a graph like this, remembering that negative 2 is our x value, I can go to the left to negative 2. So I go over to negative 2, and I find the point here at negative 2, 3. So f of negative 2 is equal to 3, because that's the output or the y value at that location. So when we're looking at these graphically, you just have to find the correct x value on the graph and then find the matching y value to go with that x value. Let's take a look at another one. Here we have a similar situation where we have a point that's been kind of removed and is outside of the normal situation, so parabola with one piece different there. And this one asks us to find f of negative 3. I'll go ahead and zoom in a little bit on this. And as you can see, so when we look at the x value of negative 3, I see that that's the part of our function here with the piece removed. So at x equals negative 3, I go up past the hole to the point, and I see that that has an output value, a y value of 2. So f of negative 3, well, that's 2, because that's the y value associated with the x value at negative 3. Okay. What do we have here? F of 3. Well, I like this graph because it's an interesting piecewise function. You can see there's nothing over here in the negative domain. Anything less than 0 is not in our domain. From 0 all the way up to 3, 0 included, we have a linear function. At 3, it drops down to its own point down here, and then everything greater than 3 is another linear function. So very neat, 3 pieces to this piecewise function. The question asks us to find f of 3, so I find the x value of 3, and I see that that's where the hole is. So I don't want to grab the hole. Instead, we go down here, and we get the correct point where the function is actually defined. So f of 3 is going to be negative 4. All right. So that's how we do it from graphs. Again, look for the correct x value and then find the corresponding y value. Be careful of the holes in the graph. You want to avoid those and look for the correct points where the filled in circles are. Let's take a look at how this is done from an equation. All right. So when we look at piecewise functions in equation form, you'll notice something about them. They have, 1, pieces. Of course, they're piecewise functions. And this particular function has 3 pieces. One piece is x squared minus 3, the next piece is negative 1, and then x minus 3. So depending on where in the domain we are, this function looks different. And this part over here on the right, where it says 4, this defines our domain. So for every value that we plug into this function that's less than 1, for x less than 1, we would use x squared minus 3, this quadratic function. If the value we want to plug in is exactly 1, the output is negative 1. So it tells us, you put it in a 1 input, you get a negative 1 output. For any value that's greater than negative 1 but less than or equal to negative 5, we would use this linear equation, x minus 3. So when you solve a problem like this, start by looking at the input value. It's 4. Which piece of the function has a 4 in the domain? Well, in this particular case, 4 is between 1 and 5, so it's the third piece of the function. So to figure out what f of 4 is, we're going to use the third piece and plug that 4 in for x, where it would be x minus 3. Now it's 4 minus 3. 4 minus 3 is 1, so f of 4 equals 1. Always plug it into the correct piece of the function based on the domain. Let's look at another one. This function is different. It only has 2 pieces. For every value that's not 5, so that's anything less than 5 or anything greater than 5, we use this quadratic value, or quadratic function. For any for x is equal to 5, we know the output is negative 3. So any other value, we'd have to plug it into the top, but for x equals 5, it's negative 3. Well, look at this. Find f of 5. Oh, it's negative 3. That's like just given to you. I'm just going to circle it like, yeah, there it is. I found it. Of course, you'd probably want to type it in the box down here. So there it is. Input of 5, output of negative 3. If I gave any other number other than 5, you would have to plug it in to the top equation. Looking at another one. Another one with 3 pieces. For everything less than 0, this function is quadratic, x squared minus 1. If x is exactly equal to 0, the output is -4. From 0 to 4, anything greater than 0, less than or equal to 4, we use this linear equation, 3/2 x plus 1. All right, so this asks us to find f of 7. So which of our domains does that go into? Well, 7's not less than 0, 7 isn't 0, and 7 isn't between 0 and 4. Well, that means that when I look at my domain over here, 7 is not in our domain. Not in our domain, that means it's undefined. So this problem we would say is undefined. That value is not in our domain. There's no output to go with it. We just can't even take that input into this function. So there you go. There's some evaluating functions review with a few piecewise examples, including the graphs there. I hope you found this helpful. Thank you for watching.